Welcome to this explainer. Today, we're diving straight into a real-world code makeover. We're going to explore how a highly specific, really granular refactoring can absolutely transform code quality. By unpacking the before and after of this project, we'll see firsthand how tiny shifts in logic can create massive improvements in readability.
So let's kick things off with a fundamental question, one that pretty much drives every programmer out there. How can we reduce friction and actually make complex logic simpler to read? Think about it. When you're staring at a screen of code, every extra mental step you have to take to understand it is basically a tax on your focus. The absolute best code doesn't just work, right? It communicates its intent immediately.
Our journey today is guided by a fascinating case study from a developer named Ang. We're unpacking part 182 of their Notes-on-Haskell-Programming, which was published back in July 2026. Ang documents this incredibly clever refactoring of a mapping table, and it really serves as the perfect example of the quest for true simplicity within the Haskell programming language.
To ground ourselves, before we get into the weeds of the code, let's define exactly what Ang is optimizing here. It's a width conversion mapping table. If you're doing text processing, this is a method used to convert standard, single-width characters into their full-width counterparts. You see this all the time with typography in different languages, like taking a standard space and converting it into a full-width CJK space, meaning Chinese, Japanese, or Korean, or applying specific numerical offsets to standard punctuation.
But here's where it gets interesting. Before this whole makeover, the conversion process was really suffering from what we can call a two-step bottleneck. The original implementation had this totally unnecessary mental hurdle built right into it. It was executing in two separate operations what really should have just been one.
The real clunkiness of that original approach was all about how it separated tasks. Step 1, the code defined raw character pairs in a simple list. Then, in an entirely separate step 2, it applied a mapping function using bimap t.pack t.pack. Now, for a little context, t.pack is used in Haskell to convert standard strings into a much more memory-efficient text data type. But by running this mapping completely separately, the data conversion process was left totally detached from the actual data itself.
Okay, so why is that actually a problem? Well, this two-step process creates a really subtle but incredibly real friction. It creates a complete disconnect between the data itself and the final structure of that data. Any developer reading this code has to look at the raw pairs and then literally map that bimap t.pack function over the pairs in their own head just to figure out what the final output is supposed to look like. It essentially forces your brain to act like a compiler, which is never, ever the goal of clean code. Recognizing that heavy cognitive overhead, Ang realized this mapping table could be beautifully streamlined into a super clean single-step solution. Instead of defining the data and then transforming it somewhere else down the line, they asked a much better question. What if we just define the data in its final form right from the very beginning?
When you compare the two approaches, the climax of this whole makeover is pretty obvious. In the old way, the mapping function is sitting totally isolated from the raw pairs it acts on, but the new approach merges those steps entirely. It defines the data directly as t.doc text pairs right inside the tuple itself. Ang took the transformation and embedded it exactly where the data lives.
So what does this look like in practice? The refactored table places the exact pairings directly into context. Standard quotes convert right to their full-width hex equivalents. A standard space converts immediately to x3000, which is that ideographic space we mentioned. We also see the logic for applying the full-width offset for characters ranging from an exclamation mark all the way to a tilde. By baking that t.pack conversion directly into the tuple definition, this elegant new structure handles the exact same logic, just without that detached mapping function getting in the way.
Now, you might be thinking, are we just shifting code around for the sake of it or just to save a few keystrokes? Absolutely not. And that brings us to the absolutely crucial why behind this entire refactoring exercise. Why does readability matter so much in software development? Because at the end of the day, code is read by humans far, far more often than it is ever written.
I think this whole thing is captured perfectly by Ang. In their notes, Ang writes, "This reduces complexity and improves readability, as we can see the resulting structure immediately." That word, immediately, is the ultimate payoff here. You don't have to trace a variable back to some distant function to figure out what type it is. The whole structure is completely visible at a single glance. It proves that the absolute best code is the code you don't even have to decipher.
As we wrap up this explainer, I want to leave you with a bit of a challenge. Take a look at your own projects, your own scripts, your own logic. Where in your codebase are you currently doing in 2 steps what you could elegantly pull off in just 1? Where are you forcing your team, or let's be honest, your future self, to mentally map functions over data instead of just showing the resulting structure right away? Finding those spots might just be your very next great code makeover.